Why Earth is formed in a round shape. Have you ever looked up at the sky, seen the glowing moon, or gazed at pictures of our planet from space and wondered, why is Earth round? Why didn't it form as a cube, a pyramid, or some jagged, uneven block drifting in space? At first glance, it might seem like a simple question, but behind this mystery lies one of the most fascinating stories of science, physics, and cosmic history. The spherical nature of Earth is not just a random occurrence. It is the result of billions of years of cosmic forces, gravity, energy, and matter working together in perfect harmony. To understand why Earth is round, we must go back in time, far beyond the age of humans, beyond the age of dinosaurs, and even before the Earth itself was born, into the swirling chaos of the early universe. The story of Earth's round shape is the story of balance, the struggle between chaos and order, destruction and creation, force and resistance. When we look at Earth from space, its spherical form is not only beautiful, but also essential for life itself. The round shape allows Earth to spin smoothly, hold onto its atmosphere, distribute sunlight, and nurture the ecosystems that sustain us. Without this perfect balance, our planet might not even exist in the way we know it. So, why is Earth round? Let's begin this journey from the very beginning, the birth of the universe and the laws of physics that made the Earth's roundness inevitable. To understand why Earth became round, we must first journey back nearly 13.8 billion years ago, to the moment of the Big Bang, the beginning of space, time, energy, and matter. In the earliest fractions of a second, the universe was unimaginably hot and dense, filled with fundamental particles moving at incredible speeds. As it expanded and cooled, these particles began to combine into simple atoms like hydrogen and helium. Over billions of years, these atoms gathered into vast clouds of gas, pulled together by the invisible but powerful hand of gravity. Gravity, the same force that pulls an apple toward the ground, was the key sculptor of all cosmic shapes, including Earth's. When matter clumped together under gravity, stars were born, galaxies formed, and massive explosions scattered heavier elements into space. Among these elements were the building blocks of planets: carbon, oxygen, silicon, and iron. In one small corner of the universe, the Milky Way galaxy, these materials came together in a rotating disk of dust and gas about 4.6 billion years ago. At the center of this disk, gravity pulled most of the material inward, igniting nuclear fusion and giving birth to our sun. Around the sun, smaller clumps of gas and dust collided, merged, and gradually formed the planets, including Earth. But here is the important part. Why did these planets, including Earth, become round instead of jagged or irregular? The answer lies in gravity's universal tendency to pull matter toward the center of mass. No matter where a particle was located, gravity tugged it inward toward the middle. Over time, as Earth gathered more and more material, its own gravitational force increased, pulling everything closer to its core. Uneven lumps and rough edges were smoothed out because gravity worked equally in all directions. The result of this constant inward pull was a shape where all points on the surface are at roughly the same distance from the center, a sphere. Of course, Earth is not a perfect sphere. Because it spins on its axis, it bulges slightly at the equator and flattens at the poles, making it an oblate spheroid rather than a perfectly round ball. But even this imperfection tells us more about the power of natural forces. While gravity pulls Earth into roundness, rotation reshapes it just slightly. Together, these forces created the balanced form we see today. Thus, the foundation of Earth's shape was laid long before humans existed, long before life emerged, and even before Earth had cooled from its fiery birth. Gravity was the artist, matter was the clay, and time was the canvas. From the chaos of the early universe, order took form, and the round Earth was born. About 4.5 billion years ago, the young Earth was not the calm, blue-green planet we know today. It was a violent, molten world, a glowing sphere of magma, fire, and constant bombardment by asteroids and comets. At first, when pieces of rock and metal clumped together to form Earth, the planet's surface was uneven and chaotic, like a jagged ball of debris. But gravity was relentless. Each massive collision released enormous energy, heating the surface until much of it melted. The heat came from three main sources: the leftover energy from collisions, the radioactive decay of unstable elements, and the compression caused by gravity itself. In this molten state, Earth was more like a liquid than a solid. Liquids naturally flow to fill in gaps and spread evenly, and when combined with gravity's inward pull, the material began settling into the most balanced shape possible, a sphere. Imagine a drop of water floating in space. Without anything to disturb it, the water forms a perfect ball because its molecules are pulled equally in all directions. Earth followed the same principle, only on a massive scale. The roundness of our planet, therefore, was not just an accident. It was the natural result of physics at work on a planetary level. As the young Earth spun on its axis, another effect came into play. The spinning motion caused the molten surface to bulge outward slightly at the equator, where centrifugal force pushed against gravity's pull. This is why Earth became an oblate spheroid rather than a perfect sphere. The difference is subtle but important. Earth's equatorial diameter is about 43 kilometers larger than the distance from pole to pole. While this might sound significant, compared to the size of Earth overall, it is almost unnoticeable. From space, Earth still appears beautifully round, a glowing blue marble suspended in darkness. During this chaotic era, another major event further shaped Earth, a colossal impact with a Mars-sized body, often called Theia. This collision blasted enormous amounts of material into orbit around Earth, eventually forming the Moon. The impact also contributed to Earth's heating and reshaping, reinforcing its rounded form. Over millions of years, as Earth cooled and hardened, the molten surface solidified into crust, but the round shape remained. Gravity had already done its work, and nothing could undo that balance. Thus, the fiery beginning of our planet was not just destructive, it was creative. The heat and collisions, combined with gravity, smoothed Earth into the rounded form we see today. Without this molten stage, Earth might have remained lopsided or irregular, incapable of spinning smoothly or holding its atmosphere evenly. The round shape was essential, a foundation that made life itself possible in the future. As Earth cooled from its fiery, molten past, its round shape became more refined and more important. But gravity alone was not the only sculptor of Earth's form. The planet's rotation, its steady spin around an invisible axis, played a vital role in shaping the Earth we know today. Every 24 hours, Earth completes one full turn, and this motion creates a subtle outward force at the equator. This is why Earth is slightly flattened at the poles and bulging at the equator, giving us its true geometric identity, an oblate spheroid. This balance between gravity and rotation is what allows Earth to remain stable. If Earth did not spin, it would likely be more perfectly spherical, but life as we know it would not exist. The spinning motion distributes energy from the sun, generating winds, weather patterns, and ocean currents that make Earth dynamic and alive. In other words, Earth's roundness is not only a shape, it is a foundation for balance, order, and life. Next comes one of Earth's most defining features, the atmosphere. The blanket of gases surrounding our planet hugs tightly to Earth because of gravity. If Earth had been an odd shape, with jagged or uneven features stretching far into space, its atmosphere would not distribute evenly. Some regions might hold thick clouds of gas, while others might be left exposed and barren. But Earth's roundness allows gravity to pull the atmosphere inward evenly, creating a protective layer of air that wraps around the globe like a shield. This shield regulates temperature, blocks harmful radiation, and holds the oxygen we breathe. Without the round shape, the atmosphere could never settle so perfectly, and life might never have found its home here. The same is true for Earth's oceans. Water, like all liquids, seeks balance. On a round planet, oceans naturally spread across the globe, filling low areas and creating a global system of seas and currents. If Earth were oddly shaped, water would collect in strange pockets, leaving much of the surface dry and barren. Instead, Our round planet supports vast oceans that cover more than 70% of its surface. These oceans distribute heat, drive the climate, and cradle the beginnings of life itself. Once again, roundness was not just a physical result, it was a requirement for survival. The round shape also allows sunlight to be distributed in a way that makes seasons, weather, and ecosystems possible. As Earth spins, different regions face the sun, creating the cycle of day and night. If Earth had a jagged form, light would scatter unevenly, causing extreme conditions that no complex life could endure. The sphere ensures balance. No matter where you're on the planet, you receive your share of daylight and night, warmth and coolness. Thus, Earth's roundness is not simply an outcome of gravity, it is the key to balance in motion, in air, in water, and in life itself. The perfect harmony of spin, atmosphere, and oceans turned Earth from a sphere of rock into a living, breathing world. Earth's round shape is not unique. It is part of a universal pattern. When we look across the solar system, we see that almost every large planet and moon is round. Jupiter, Saturn, Venus, Mars, Neptune, and Uranus all appear as giant spheres floating in the cosmic sea. Even our moon, though smaller than Earth, is also rounded.
Why?
Because gravity does not play favorites. The same force that smoothed Earth into a sphere works on every massive body in space. The principle is simple. If an object is large enough, its own gravity overpowers the rigid strength of rock or ice. Over millions of years, gravity pulls the object's material inward, ironing out sharp edges and uneven terrain until it settles into a sphere. Smaller objects, like asteroids and comets, are different. They don't have enough gravity to reshape themselves, so they remain jagged, potato-shaped, or irregular. This is why many asteroids look lumpy or broken, while planets and large moons look round. Earth's size, therefore, was essential. Because it was massive enough, its gravity ensured that roundness was unavoidable. Comparing Earth with its neighbors helps us appreciate this even more. Jupiter, the giant of our solar system, is not a perfect sphere either. It is more flattened at the poles and bulging at the equator than Earth because it spins much faster. A day on Jupiter is less than 10 hours, which means its rotation stretches its equator dramatically. Saturn, with its magnificent rings, shows the same effect, appearing almost squashed when viewed through telescopes. Earth, with its slower rotation, is less dramatically flattened, making its roundness closer to a perfect sphere compared to the gas giants. Even the Moon provides an interesting comparison. While round overall, the Moon is slightly lopsided, with more mass concentrated on one side. This unevenness is the reason the same side of the Moon always faces Earth. Gravity locked it into what scientists call tidal locking. Yet despite this imbalance, the Moon's general form is still spherical, showing gravity's dominance in shaping celestial bodies. This universal roundness tells us something profound. Roundness is nature's most efficient shape under the influence of gravity. It represents balance. It minimizes energy. It is the natural outcome when forces have enough time and power to smooth things out. From tiny water droplets floating in microgravity to massive stars like our Sun, the sphere appears again and again as the favored form of the universe. Earth is not just round because it happens to be, it is round because it must be. By seeing Earth alongside other planets and moons, we realize that roundness is not simply an aesthetic feature, it is a cosmic rule. It connects our planet to the grand design of the solar system and beyond. In fact, being round is part of what qualifies an object to be called a planet in the first place. The International Astronomical Union defines a planet as a body that orbits a star, clears its orbit of debris, and is massive enough for gravity to shape it into a round form. Roundness, therefore, is not just a byproduct, it is the very definition of planethood. When we look at Earth's roundness, we might think of it as simply a physical outcome of gravity and cosmic laws. But the truth runs much deeper. This very shape is the silent architect of life. Without the balance provided by Earth's spherical form, our planet could never have nurtured ecosystems, species, and eventually human civilization. The first way roundness supports life is through the even distribution of sunlight. Because Earth is spherical, sunlight spreads across the surface in a smooth pattern. Different regions receive varying amounts of light depending on latitude, which gives rise to the equator's tropical heat, the temperate zone's balanced climate, and the poles' icy cold. This variation creates the diversity of ecosystems, jungles, deserts, grasslands, and tundras, that make Earth a living masterpiece. If Earth had been shaped irregularly, sunlight would not distribute evenly, and vast areas could have been unlivable wastelands. Roundness ensures balance between hot and cold, light and dark. Secondly, Earth's shape enables the cycle of day and night. As a round planet spins, one side faces the sun while the other turns away, creating alternating periods of light and darkness. This rhythm became the foundation of biological life. Plants evolved to open during daylight for photosynthesis and rest during night. Animals adapted to diurnal or nocturnal lifestyles. Humans built their lives around the rising and setting of the sun. Civilization itself, work, rest, culture, timekeeping, emerged from Earth's round spin. Without a sphere turning on its axis, this universal rhythm would collapse. The round shape also plays a role in the distribution of gravity itself. On a sphere, gravity pulls equally toward the center, which means objects experience nearly uniform weight no matter where they stand. Imagine if Earth were shaped like a cube or jagged rock. Gravity would act unevenly, pulling stronger in some corners and weaker in others. Seas would pool oddly, the atmosphere would shift unpredictably, and daily life would be unstable. Instead, the sphere allows stability. Oceans form seas, rivers flow downhill, air wraps evenly, and humans can build homes, farms, and cities without fear of gravity tearing balance apart. Furthermore, roundness allows Earth to maintain a protective magnetic field. Deep within, molten iron churns in circular motions, creating a magnetic shield around the planet. This shield deflects harmful solar radiation and cosmic rays, protecting life from deadly exposure. The existence of such a field is directly tied to Earth's shape, spin, and molten core, all consequences of its round form. Without it, our atmosphere would have been stripped away long ago, leaving Earth barren like Mars. Even human culture has been shaped by Earth's roundness. Ancient navigators followed the curved horizon to sail across seas, discovering lands and connecting civilizations. The curved Earth allowed explorers to circle the globe, proving once and for all that we live on a sphere. Today, satellite technology relies on Earth's roundness to orbit smoothly, giving us global communication, weather prediction, and navigation. Our very progress as a species depends on the planet's form. In every sense, biological, environmental, and cultural, Earth's roundness is not just a scientific detail. It is the foundation of life, stability, and civilization. Our home is not a cube, not a jagged stone, but a rounded world perfectly shaped for the miracle of existence. From the very beginning of the universe to the present day, the roundness of Earth has been both inevitable and miraculous. Born from the chaos of the Big Bang, shaped by the force of gravity, smoothed by molten heat, and balanced by its steady rotation, Earth emerged as a nearly perfect sphere in the vastness of space. Its form is not a coincidence. It is the product of universal laws that sculpt order from disorder, balance from chaos, and beauty from raw matter. The round shape of Earth is far more than an aesthetic feature. It is the silent blueprint of survival. A sphere allows sunlight to spread evenly, nurturing climates and ecosystems. It lets gravity act uniformly, stabilizing oceans, mountains, and the very ground beneath our feet. It supports the atmosphere and oceans, creating the cycles of weather, water, and life. It gives rise to day and night, the rhythm upon which all living beings depend. Even human civilization, with its navigation, exploration, and scientific progress, owes much to the curve of the horizon and the balance of a globe. Yet Earth's roundness is not only about science, it is about meaning. When astronauts first looked back from space and saw the glowing blue sphere suspended in the blackness, humanity realized something profound. We all share one home. The round Earth has no edges, no boundaries. It is one continuous whole. From space, nations disappear and divisions vanish. All that remains is a fragile, beautiful sphere, carrying oceans, forests, deserts, animals, and people together through the cosmos. Why is Earth round? Because roundness is nature's most balanced and efficient form under the power of gravity. Because spheres minimize chaos and maximize harmony. Because without roundness, there would be no atmosphere, no oceans, no life, and no us. In its shape lies a story that is both cosmic and personal, both scientific and spiritual. The round Earth is a reminder that we are part of a vast universe governed by timeless laws, yet blessed with a planet uniquely suited for life. So the next time you see the sun set over the curved horizon, or gaze at the pictures of Earth from space, remember this. You are standing on a miracle of geometry, physics, and chance, a round world, perfectly shaped to cradle existence. Earth is not just a planet. It is a sphere of life, balance, and wonder, carrying all of us on its endless journey through the stars.